get started.
So, welcome everybody. My name is Tahsin. I work with, I recently joined Wayfair. It's a furniture e-commerce company. Today we will talk about code sharing, specifically with Kotlin Multiplatform.
Yeah, exactly. So while we're working together at Novoda, we had some time between our projects and we had the chance to spike Kotlin Multiplatform, and we want to share our learnings with you guys today. Novoda is a Berlin-based company, agency / consultancy. And yeah, so now you know us a bit. Now we would like you to know a bit better. So I would like to know who of you writes Kotlin code, like on daily basis? Wow, wow, wow. I mean, so surprising for a Kotlin event, right?
What about, Kotlin is popular recently, is much popular with Android developers. Who is writing Kotlin but not for Android? Web, backend, or, that's cool. What about iOS? Okay.
Do we have some iOS developers in the crowd today? Anyone? Yeah, great. Good, welcome. So we're gonna show some code. And it looks like Swift, but it's Kotlin. It's a new programming language from JetBrains, yeah? Okay.
So don't get confused.
Just kidding.
Yeah.
So why do we ask this? Today we're gonna talk about how we can share code between the different platforms. Web frontend, backend, mobile, Android, and yes, even iOS. And we want to start this talk with a really bold statement. So this technology might really be a game changer when it comes to the collaboration between iOS and Android teams. So stay tuned.
Yeah. Oops. Yeah. So we will start with understanding why do we even share code in general, not Kotlin specific. So first of all, when you read about cross-platform frameworks, the most important thing you will see in post articles is the cost. Many companies are not that big, especially startups. They may not have so many developers. So having more developers is of course costly. So if you don't have that many developers, so it makes sense. Even when you have many, it may make sense to develop once and deploy to Android and iOS. Maybe if you do JavaScript, maybe JavaScript developers may contribute as well. Mainly these kind of comparisons comes to the cost, of course.
Yeah, but not just cost, we also benefit a lot from shared code when it comes to quality, right? I mean, nowadays when we have a look on GitHub, all the famous libraries, they all have their CI badge attached. They display how much test coverage they have. And we all know this. As soon as we start sharing code among our company or even with the community, we make sure that this code is good and makes sense for other people to use. But the question is, I mean, this all happens horizontally, right, on a technology stack like Android frameworks. But why don't we share so much code vertically in a company? I mean, nowadays we work a lot in feature team setups where we have a team consisting of backend developers, front-end developers, mobile developers, but we don't see much code actually being shared among these people. And the reason is quite obvious because we have different technology stacks. So the backend guys are deploying their web services in Go. The web front-end team is fighting with the latest JavaScript framework. And we Android developers write Kotlin code. iOS people write Swift code. So it's really hard to share code.
So we will go ahead and do some. Okay, this is better, right? So we will do some comparison with the other, especially mobile-focused cross-platform frameworks or SDKs. it's obviously becoming more popular and popular to use such frameworks. So there's like React Native. It's really hot these days. Facebook and Airbnb are like using that a lot. And there is like Google recently released Flutter. It recently became beta. So Google has, although it owns Android as well, it has a huge focus on Flutter as well. Even within Google, they compete in each other. So and there's Xamarin and PhoneGap, right? So we will see what difference does Kotlin have. So Kotlin takes a lot simpler approach in this case to when it comes to shared code. So let's see if it is going to be another player in the market.
Yeah, exactly. So when we look at these traditional tools, React Native, Flutter, I mean, what they try to do is they try to abstract for you the platform away, right? So you have one API and you use this API in order to deploy the same feature to different platforms. But this approach obviously comes with a lot of drawbacks, right? I mean, we have different platforms, they all have their quirks, just thinking about the different navigation patterns that we have in iOS and Android. And we still need platform experts for the different SDKs, for ads and tracking. So in the end, what does it mean? We need platform experts to deal with platform concerns, plus we need framework experts that are able to deal with React Native and all these things. And yeah, so what do we win actually?
Yeah, so let's see why actually sharing code is even difficult, right?
Yeah. So, I mean, as Tahsin mentioned, just, you know, Kotlin Multiplatform takes the approach to share your business logic rather than your view implementation code. So that sounds easy, right? So just take your business logic, extract it to a different module, share it, publish it, and the job is done. But you know, why is not everyone already doing this? Well, because doing this is actually one of the hardest challenges we face in software development, and especially on mobile, where projects started as like side projects to enterprise, web, and desktop applications. On these platforms, we can look back to decades of experience. We have software architects that do nothing else than separating business concerns from platform concerns. And yeah, and on mobile, we have more a younger generation of developers with not so much experience, and also traditional, like how companies deal with these mobile products. We see a lot of legacy code actually, and that makes it really hard to share code.
Yeah, so we will, so what you see here is like two superheroes. They represent iOS and Android developers in your company. So, you know, they develop features a lot, so they celebrate the successes, like it's going all great so far. But I'm sure there are managers in this audience as well. So, like, you know, you guys here heard about our talk now. So what will happen tomorrow? You will probably go back to your company, and this talk is recorded. Maybe we will share, and you will show that to developers, and you know, it sounds great. So you will probably try to apply what you see here. So let's see if it is gonna be that easy just to apply.
Yeah, so your boss comes to you and tells you, hey man, so I have heard of this awesome talk. We can now share our business logic in Kotlin. Let's do it, right? And then you sit on your chair, your heart starts suddenly beating, you start sweating, you're looking at your famous home activity or home view controller, and you scroll the class down to the bottom, like all the way. You're like still scrolling, and then it tells you, wow, 3,000 lines of code. And then you realize, what the fuck have I done?
Real story.
Yeah, real story. So yeah, if you are this developer, or if you are the boss of such developer, then we have a couple of good news for you today. The first one is Kotlin Multiplatform is still experimental. so you still have some time to clean your stuff up, no worries. The other one is Novoda might help, so don't hesitate to get in touch with us. We are happy to help you out of that situation. Marketing check, yeah? And the other one, we're gonna give you some entry points and some little hints how you can at least like realize if you are in a situation that you could apply and use such tool or not. And why? Because it's really, we think it's really, really important. If you are not able to clearly separate your business rules from your presentation and platform concerns, then you won't be able to use this tool, and that would be really sad.
Yeah, so we will now look at like this will not be a big architecture tool. Of course, architecture is really important in this case. But we will talk a little bit about like some principles that you should focus to modify your architecture to make it easier to adopt Kotlin, which is not just for Kotlin, it's always beneficial. So who knows this guy? Yeah. So it's Uncle Bob. So he is like one of the most important peoples in recent maybe software craftsmanship history. So he has lots of books like Clean Code, Clean Coder, and recently Clean Architecture. So we will talk a little bit like some statements that he has in the book. So we will focus on just two of them.
Yeah, so he's one of the guys that has these decades of experience looking back to his previous projects. And yeah, one famous statement from him is your delivery mechanism the delivery mechanism is an annoying detail. What does that mean? So when he speaks about the delivery mechanism, he talks about the target platform where you deploy your application. So you have a web application, then the web is an annoying detail. The web shouldn't be prominent in your application. Your application shouldn't tell much about the web. This is just a deployment target. Same goes for Android, right? An Android application is an application that is deployed to Android. Android is not the focus, it's the business rules that are the focus. And so when you write code and design your architecture, always ask yourself, are you able to quickly deploy your application to a different platform actually? Would that be possible? And you could even go a step further, do it for Android. Replace your UI with a command line interface. You would be surprised what kind of possibilities you suddenly would see, how you could build a little DSL around your business logic, use it for integration tests. There are a lot of possibilities, and all these things, they will help you a lot to really focus on what's important for your code. And if you can already do this, then thumbs up.
Yeah, the second statement is what he calls the screaming architecture. So when you look at your code base, when you look at your architecture, packaging structure, it shouldn't scream the platform you're developing on. So for example, it shouldn't, when you look just by looking at the structure, it shouldn't tell you that this is an Android application. Like in early days, lots of examples even provided by Google, maybe some of them still are, like had package names like activity fragment, you put all your activities in there. So yeah, even it's literally a class name from Android. So instead, what you should have is that when you look at it, it should like maybe say, I am a real estate search application, or I am an e-commerce application, right? Yeah, so this is a really solid principle.
Yeah.
When it comes to.
And now finally, Kotlin Multiplatform. Yay! Enough of this architecture talk. So Kotlin Multiplatform is a feature or a tool that has been integrated into Kotlin. It enables you to deploy Kotlin code to different platforms: JVM, JS, JavaScript, and native. It uses therefore tools. Kotlin JS, which compiles Kotlin code to JavaScript, Kotlin native, which deploys Kotlin code to native platforms. And this has been recently added to Kotlin Multiplatform. And Kotlin Multiplatform itself comes with a Gradle plugin that allows you to have a multi-platform project where you have a common module and different platform modules. That's the big win, I would say. And when we look at the Gradle plugin, so this is like the minimal configuration for a common module, I would say. You can see that there's a new plugin, Kotlin Platform Common. You apply this to your common module, and this is the module where your business logic lives, right? You should also just have dependency to the Kotlin standard library. There's even a specific test dependency that you can use. That's very easy. And then you have a platform. In this case, it's a common JVM. Why is it common? Because we might have multiple JVM clients. Just imagine a JVM desktop client and an Android client. And what we can see here is we have a different plugin, Kotlin Multiplatform JVM, and we have this keyword expected by. And through this keyword, we basically link our platform module with the common module. This is the link.
Yeah, it literally says that this implementation is expected by the common, because common doesn't have this JVM specific implementation.
Yeah, and then you have your actual client. In this case, it's a desktop client. And the only thing what you do, you have a compile dependency to your common JVM module, so you can use all the JVM specific code in there, and you're ready to go.
Yeah, also like one of the main difference of Kotlin Multiplatform is that, you know, Kotlin for iOS has been around a little bit more than Multiplatform. Multiplatform allows you to have everything in single code base. So Kotlin Multiplatform adds only this expect and actual keyword you see here. It's nothing more. When you have the plugin applied, you just have access to just these two keywords. And as you can see here, like when you focus on the expect class, it looks like an interface actually. But additionally, you see that it has a constructor, maybe a little bit also like abstract class. But it's a little bit different. So it becomes much easier with this. So you have this expect in your common module, and then every platform has to have the actual implementations. So you can have here like actual fun writing this code. So like one difference is that, you know, when you have the classic approach, when you have an interface, you implement it, of course, for different platforms. But here Kotlin forces you to have exactly one implementation for each platform. It will tell you, and it's in the IDE, it's super easy to jump between different implementations. So the second difference is that, you know, when you have a simple interface or protocol in Swift, when you implement it, you have to have different names. You know, in simple approaches, it's like naming is hard, of course. And here, as you can see, they have the same package, same class name, exactly same names. Makes things easier. And another thing is that, you know, when you have a simple interface again, the interface itself in the common module cannot be instantiated. It's just like that, because the constructor and the implementation lives in different platforms, and those platform packages can instantiate it. But here, like one little thing more, but it makes it also easier. You can just instantiate this class inside the common module. So it makes it easier.
Yeah. So we were talking about an example, and as you can see, we are really bad designers, but we do our best to be better coders. So what we have done is we implemented Convol's Game of Life as a multi-platform project. The Convol Game of Life is a cell production, reproduction simulation. As you can see, it simulates something. It follows some simple rules. And we took this because it has simple rules. It has a clear separation between business rules and presentation. So we thought it might be a good example. So we're gonna take it. What we did is we implemented a React web frontend client using Kotlin.js. That's this beautiful client. Yeah. Then we added an Android client. And 2 weeks ago, since Kotlin Native has been part of the multi-platform toolchain, we also added an iOS client. Yeah, and we're gonna have a look.
Yeah, so we took a really simple approach. Basically, when you look at the game, it starts with some cell, and then you have iteration given a period. So every iteration, the cell transforms into something else. So we called it game loop. It's a loop. You start with some interval, and it's an asynchronous operation. Of course, every interval you have this onTick implemented. Yeah, and here we use the expect class, and this will be implemented by differently by each platform.
Exactly. So the first implementation is the JVM client, and as we can see here, we just use RxJava, straightforward. So this is our game loop implementation. We have some flowable interval with the interval, so we subscribe to it, we call on tick, the job is done. Easy.
Yeah. So here is the JavaScript implementation. Like I really don't have much JavaScript experience, so we could use RxJS as well here, but I don't know. We found this window object from browser package, so it has this set interval. So just also, it's a good example. We have a different implementation here doing the same thing for JavaScript. Yeah, it worked out. We had actual fun here.
Again. And this is the Kotlin native implementation. And this looks kind of suspicious, right? I mean, here, what do we have? NS timer. What is this? I've never heard of this. NS run loop. That's like black magic. And it's not Swift, it's still Kotlin, by the way. And how is this possible? Well, what we're using here is a feature from the Kotlin native compiler, the interoperability feature, and it allows you basically to generate Kotlin bindings for any kind of C library, which is really a powerful feature, right? And this means you can call from your Kotlin code any C code in theory. And even more, the compiler is shipped with the whole iOS SDK. So what does it mean? In theory, you could write your whole iOS application in Kotlin. Yes, you could.
Do we have to?
No, we don't have to. We will still keep your job, don't worry. No, as we said in the beginning, we should focus on this part on platform concerns, or basically we should leave the platform concerns to the platform experts, right? We should focus on fulfilling the contract for our multi-platform purpose, but anything else we should leave to the platform experts actually. Yeah, and since the Kotlin native implementation is a bit more interesting, let's have a look at the Gradle plugin for this. And what we can see is we apply the Kotlin native plugin, right? And then we need to specify targets, Conan targets. In this example, we use the iPhone and iPhone simulator. And then we can specify a Conan artifact. And this artifact can be either an executable that you then can execute from the command line, or a framework. And this is an Xcode framework. And so what you will get is an Xcode framework that you then can just include in your Xcode. And what you need to do is you need to enable multi-platform manually. You still have your dependency here, expected project, that's similar to the Gradle plugin for the JVM and JavaScript. And there's even enable debug true. This is working since actually 1.5 weeks or so. You can debug your Kotlin code from Xcode using LLDB, which is like black magic, really black magic. But it's working, and it was working fine.
Yeah, so let's look into, this was the summary of our example project. So this was just a game of life, game loop classes, right? This game loop has different implementation for each platform, but the rest is actually all in the common. So what did we share in the sample project? So first of all, the entities, entities is like easiest to share. You know, they are the simple like you may call them traditionally POJOs in Java, so they are value objects, not much logic inside, they represent the data, really easy to share. And then secondly, we have models. So this is where we have control over the data. So this is where we have our business logic mostly. So this is all in the common module. It uses the game loop. It can instantiate the game loop, and immediately you will get whatever platform you have. You will get the instance of the game loop. Also in tests. So when we have a test of this business logic, it's also in the common. You run it. It runs it 3 times, like whatever, like not 3, but whatever number of. Yeah, it has some. It may have some challenges, but when it works, it potentially runs your test in each platform, because you have different implementations of the expected classes or interfaces, whatever. So that's really good. And here we even shared the presentation logic. So it was also super easy, since we could instantiate classes also in the common module, right? So when we abstracted away the view interfaces, you know, we were able to abstract the lifecycle logic of the different platforms. In the view level, our application was also simple, but at the end, Android, iOS has similar lifecycle. So we abstracted that away, and then we were able to have a single presenter in the common code.
Yeah, so what was basically left? Passive views. So we're going to share the link to the GitHub repo with you later. And the only thing left in the platform implementations is basically, for example, speaking of Android, implementing the view interface in your custom view class, on start and on stop, creating the presenter, binding the view to it, done. Yeah, and this was really, really, really impressive.
Yeah, also like one surprise we had, like we had also the desktop client Gradle code in the beginning. So this was really a surprise. We were really happy in the company. We shared it immediately with everybody. So there was this PR opened that was adding the desktop client. So somebody else did this, and it was super easy to implement, because in this passive views, you don't have logic. So it was really straightforward to review, and we merged it right away.
Yeah, exactly. So what's missing in order to make this technology production ready? One thing is multi-threading. When we think of Kotlin, we may think of coroutines, right? They are available. They're now also available for JavaScript. But for Kotlin native, there are unfortunately not yet bindings available. So the compiler understands coroutines, but we don't have bindings, because these, like the keywords for coroutines, launch and whatever they have, they are like not part of the standard library. They're like extra bindings.
Also, to be honest, we were afraid that this might change, like today or yesterday, because Kotlin team is like launching features really fast.
Yeah. The other one is like lots of applications rely nowadays on reactive code, on reactive patterns, and there's no common reactive model, right? I mean, we have RX Java, RX Swift, RX JS, but there's no RX whatever that everyone depends on, right? So, but there are also initiatives going on, like Jack Wharton, which is a famous guy in the iOS community, the Android community. Is this recorded? No, I hope not. So he is working on Reagent, it's called. It's something like where he tries to abstract this reactive approach for us. And yeah, what else is missing? Like a caching abstraction, a better testing support, as Tahsin mentioned. Testing is still a bit challenging, because, for example, there's no mocking framework that supports native, Kotlin native, and that makes it obviously a bit hard to write like really good tests. And yeah, SDK integration, that would be something to consider.
Yeah, here, one thing we did in the project, we abstracted away also the logger class. We had different implementations, so like some companies like advertisement, they may not provide Kotlin SDKs, but it's also super easy for you to abstract away this to share code.
Yeah. So now we have a couple of links. The first one is the repo for the Game of Life, including all the clients. So if you're interested into, then have a look. And the other ones, we published 2 blog posts, one regarding multi-platform, and the other one specifically around the Kotlin native integration. And that's it.
Thank you very much.
Thanks.
So how long do we have now?
Right on time. We have time for awesome questions, and we have some gifts. Speakers will decide which questions qualify.
Oh.
So please ask your questions, and speakers will find answers.
How many gifts we have?
Let's talk about gifts.
A lot. 2 for each talk.
Come again?
Yeah.
Should be explicitly useful for multi-platform because you have type alias or expected interface or something. Have you tried that, or is that all used by the compiler and you don't have to?
No, that works. For example, the test annotation, you have JUnit test, so it is like you expect test to be available, so you have that in the comment, but you can have an implementation of that, or you can also just use type alias. Works.
Yep.
So we have heard about this kind of approach before from Google, I guess, with Inbox and stuff. And from what I've heard, they use the Google Web Toolkit and J2 Objective-C, which are both Google projects, which kind of go into the same direction. So how do you guys compare that? Why is this better than the other tooling?
So one big difference is Kotlin native and Kotlin multi-platform are different things. Kotlin native is kind of similar to the J2 Objective-C, right? Which compiles Java code to Objective-C code. But multi-platform is a tool that enables you to have a single project where you have common code and different platform clients. I think this is one of the main differences when it comes to the multi-platform approach. Other than that, one big advantage for J2 Objective-C is for sure that any kind of Java code is actually transferred to Objective-C, which means you can also have Java libraries, right? Which for Kotlin native, that doesn't work. So you need to have pure Kotlin, so that might be even a drawback for that.
We had some a section in the blog post as well.
It should work.
One more question, and then one more. Last question, yes, let's go for it.
I'm not an expert in building iOS apps. I've never done it, but they probably have different build tools than Gradle. How can I use Gradle and then include the stuff into an iOS app?
Yep. So let's go back here. So the similar issue you also have with the web frontend client, because they also have suddenly the break between Gradle and Node, because the React client is also built with Node. And here it's similar. So the toolchain basically ends by generating the Xcode framework. And with the Xcode framework, you're then free to do whatever you want to do. So what we did, we manually implemented it or included it in our Xcode project. Exactly. Exactly.
Yeah. For JavaScript as well, you can separate the common implementation of JavaScript or native implementation of the common library, and then it's just a library that you can use in JavaScript or Xcode project. Is that it?
Awesome. Thank you very much for your awesome talk.
What about the gifts?
We'll make it.
Okay.
3 people who ask questions, please come to me after on the break, not right now.
Cool.
Thank you.
Yeah, enjoy the evening.
Thank you very much.